Welcome to the deep dive. Today, we're tackling something really fundamental, but maybe a bit hidden, industrial infrastructure.
Right. The stuff that keeps everything running behind the scenes. Hospitals, telecoms, you name it.
Exactly. And our goal for you today is, well, pretty straightforward. We've got some great materials here, and we want to unpack them so you get the key knowledge fast. How do we make this invisible stuff visible and smart?
Yeah, and one thing that jumps right out from the sources is this core challenge, data blindness.
Data blindness.
About, what is it, 70% of industrial gear it uses older ways of communicating, proprietary stuff.
Okay, so it's like they're all speaking different kind of outdated languages.
You got it. That means you just can't see what's actually going on inside. You're missing the full picture.
Right. The analytics brief really hits on that. If you can't see it, you miss insights, you react slowly.
And it sounds like a real headache just managing it all. You know, different vendors needing unique gateways for each one.
Like needing a different translator for every single machine.
Exactly. Adds complexity, costs more, takes engineers longer in the field, just slows everything down.
Okay, so that's one side, the lack of data. But what about when you do get data?
Ah, yeah. Then you often hit the opposite problem. Information overload.
Like the hospital example, what was it?
Over 20,000 data points daily from just a mid-sized hospital.
Wow. Okay, that's a lot for a person to sift through.
Totally overwhelming. And the usual fix, these rule-based alarms, they don't seem to work very well.
The sources said something like 95% false positives, is that right?
Yeah, up to 95%. So you're chasing ghosts most of the time.
Which probably explains why predictive analytics, the stuff that could really help, hasn't taken off as much. Less than 15% adoption.
Well, yeah. It often means messing with the equipment's firmware, needing data science specialists. It's a big hurdle.
So you're either blind or you're drowning in noisy data, and the smart solutions are hard to implement.
Pretty much. And this all leads to slow responses when things do go wrong.
Right. Someone has to physically go out there.
And that takes time. Average field response over 3 hours, the brief says.
And downtime. That costs a fortune, doesn't it?
Yeah. Can be upwards of $250,000 an hour. The costs rack up incredibly fast.
Okay, so the picture is clear. Invisible assets, data overload, slow reactions, huge costs. Not great.
Definitely not. But the materials lay out a framework to tackle this. They call it See, Know, Act.
See, no, act. Okay, I like it. Sounds logical. Let's break that down. How does it work? Where do we start?
We start with C, collect and aggregate.
Makes sense. First, you need to actually get the data.
Exactly. The idea is to have one place, a unified platform that can actually understand all those different industrial protocols.
The weird languages we mentioned, like Modbus, RTU, BACnet, MSTP, those examples from the brief.
Those are common ones. Think of them like different types of data plugs. You need something that can handle all of them.
And that something seems to be this Phantom Shield gateway. Is that the key piece here?
It looks like a central part of it, yeah. It could be a physical box or even virtual software.
And the point is, it connects directly without needing extra software layers like middleware.
Right. It simplifies things. It acts like a universal adapter or maybe a translator, pulling in all these different data streams.
Okay, so it grabs the data, but just having raw data isn't enough, is it?
Nope. That's where the next part comes in. Normalization and contextualization.
Meaning?
Making it all speak the same language after collection. Standardizing the format, and adding context like tagging it, timestamping it correctly, saying which machine it came from, so it actually means something.
Got it. So C is about getting all the data from all the different sources into one place in a format that makes sense.
Precisely. Now we can move on.
Okay, we've seen it. What's next? No?
Yep. No. Detect, decide, learn, and improve.
Yeah.
This is where the magic starts to happen, turning that data into actual intelligence.
And the cool thing here, mentioned in the materials, is doing this without messing with the old equipment's basic software, the firmware.
That's a huge plus. You can add smarts, like business rules or anomaly detection, without risky or complicated updates to the legacy gear itself.
So how does it detect problems? The brief mentioned golden fingerprints. What's that about?
Think of it like learning the unique heartbeat of each machine, a pump, a generator, whatever.
It's normal operating signature.
Exactly. These device agents' software bits basically learn that normal pattern, that fingerprint.
And they run right there, locally, on the gateway or maybe in the cloud.
Yeah, either way. And because they know what's normal, they can spot tiny deviations really fast. Under 50 milliseconds, apparently.
So not just waiting for a major failure alarm, but catching subtle things, like a sensor starting to drift off.
Right, early warnings. Much more proactive.
Okay, that's the individual device level. What about the bigger picture, site agents?
So site agents operate at the next level up, usually in the Reveal Cloud platform. They look across multiple devices at one location.
Connecting the dots.
Exactly. They correlate events. Let's say a pump reading changes and a valve status changes. The site agent figures out the connection.
Ah, root cause analysis, RCA, using these causal graphs.
Mm-hmm. Like a logic map to trace back what really caused the issue, not just the symptoms. And they can even predict failures.
Predict. How far out?
Up to 7 days, the sources suggest, giving you a heads-up score.
That's pretty useful. Okay, so device agents watch the individuals, site agents watch the site. What's next? Fleet agents.
Now we're zooming out further. Fleet agents work across all the connected sites. And this is where federated learning comes in.
Federated learning, that's the approach where you learn from lots of data without actually sharing the raw data, right? Privacy preserving.
Exactly. The agents on each site learn locally, then they share anonymized updates. Just the learnings, not the sensitive data, to help build a better central global model.
So everyone benefits from the collective experience without exposing their specific operational data.
Right. This global model can then benchmark sites against each other, suggest better settings.
Thanks.
It's like a cooperative intelligence network.
Very cool. A whole swarm of AI agents learning together. And the ultimate goal is this global orchestrator.
That seems to be the long-term vision, yeah. Millions of agents coordinating autonomously. Big picture stuff.
And it's not just rules or just machine learning, but both working together.
Yes, using rules for known conditions and ML for spotting those subtle drifts and new anomalies. And always learning, refining the models based on feedback.
Okay, so know is really about understanding what's happening, why it's happening, and what might happen next.
You got it. Deep understanding.
Which brings us to the final step. Act, automate.
Right. Closing the loop. The system doesn't just tell you there's a problem, it can potentially do something about it.
How does that work?
Reveal can correlate signals. If this happens, then do that. It can automatically trigger actions on other connected devices or systems.
And the key difference from traditional systems, like a BMS or PLC, is that you don't need complex, costly reprogramming to make different systems talk to each other for these automated actions.
That's the idea. Reveal acts as the orchestrator. Imagine detecting a coolant leak predictor and automatically adjusting a failure set point, or notifying maintenance and ordering a part.
And that multi-agent scheduler they mentioned, optimizing power, maintenance, even carbon emissions across different continents.
Yeah, that points to a really sophisticated level of automated control and optimization, coordinating resources intelligently on a large scale.
Okay, see, no act. It provides a solid structure. Now let's maybe dig into the specifics of the Reveal platform itself. The Strategy 2025 doc had a lot of detail.
Sure, it shows the evolution. Started with the basics: data logs, event logs, alerts via email, WhatsApp.
But looking ahead, they're planning integrations with ticketing systems, collaboration tools, even AI phone calls for alerts.
I think so. And improving insights with visualization tools like Apache Superset.
The big push for 2025 seems to be AI agents and APIs, though.
Definitely. And this new asset tracking module sounds interesting too.
Right. It's for managing inventory, warranties, maintenance, even if the device isn't actually connected to Reveal yet.
Yeah, it's like a stepping stone. Get your asset house in order first, then connect the critical ones. Helps identify opportunities too.
And the alerts are getting smarter. AI-enhanced alert agent.
Mm-hmm. Embedding that RCA, the predictive stuff, and even dynamic playbooks, step-by-step guides right into the alert, so you know what to do immediately.
That sounds much more useful than just a simple something's wrong message. And AI-powered reports, too.
Yeah, the Schedule Reports AI agent uses large language models, LLMs, to generate summaries and tailored insights. Makes the data easier to digest.
Plus, a natural language interface for setting up your own rules, that could make it more accessible.
For sure. Less reliance on engineers for simple customizations.
And they talked about rolling out those component and site AI agents in phases, building towards that bigger vision of cross-site learning.
Yeah, that federated and reinforcement learning approach, it's a clear roadmap towards more autonomy.
What about Reveal Flex, integrating LoRa sensors?
That looks like a way to bring in data from other types of low-power, wide-area sensors using third-party gateways. And the freemium model might encourage people to try it out.
Makes sense. Expand the ecosystem. And an API dashboard, a pro certification program. It all points to building a more mature, integrated platform.
Absolutely. And strengthening the edge computing in the Phantom Shield for faster local decisions is key, too.
Keeps things running, even if cloud connection drops.
Exactly. Plus, that continued emphasis on federated learning for privacy and adding adaptive cybersecurity, which is crucial when you connect all this industrial gear.
And the virtual Phantom Shield option gives flexibility for cloud-based setups.
Okay, lots of platform capabilities. How does this translate into actual solutions? The brochures gave some concrete examples.
Right, like energy management. Combine smart meters, the Phantom Shield, and Reveal.
And you get centralized, intelligent control over energy use. Yeah. Benefits like efficiency gains, cost savings, remote monitoring, predictive maintenance on electrical gear, even help with compliance.
The alerts for high usage or outages and the dashboards showing trends seem key to making it actionable.
Definitely. And the implementation seems pretty standard. Install meters, connect gateway, analyze data.
Similar story for fluid monitoring, fuel tanks, water levels.
Yep. High-precision sensors, ultrasonic, radar, whatever fits, feeding data into Reveal.
So you can prevent runouts or overflows, optimize deliveries.
Reduce costs, detect leaks or contamination early with specific alerts for sudden drops or sensor issues. Again, dashboards provide the visibility.
Okay, energy fluids. What about security, CCTV?
That's another angle. Integrating IP cameras with Reveal's event system.
So an alert triggers a snapshot or lets security view live video immediately.
Exactly. Plus, monitoring the health of the CCTV system itself, recorder status, disk health, camera uptime, with multi-brand compatibility.
So it's not just using the cameras, but making sure the surveillance system itself is working reliably.
All right. Alerts for signal loss, hardware failure, full storage, high temperatures, keeping the security infrastructure healthy.
And IT infrastructure monitoring, focusing on servers.
Similar principle. Real-time monitoring of server health, performance, resources, using tools like IBM Flex System Manager, integrating that data.
Proactive problem detection, optimizing server use, automated alerts based on thresholds.
Yeah, using an intelligent rules engine, centralizing alerts, even linking with physical security if needed. It's about ensuring IT uptime.
So across energy, fluids, CCTV, IT, it's the same core idea. Connect the assets, apply intelligence, get alerts, see trends, automate where possible.
That's the pattern. See? No, act. Apply to different domains.
Now let's talk business. Does this actually work in the market? What did the Analytix brief and GSS presentations say about traction?
Well, the market itself is huge. Industrial IoT projected at over $340 billion by 2025. Significant growth.
And Analytix is targeting those blind spots we discussed earlier.
Exactly. Their model seems to be land and expand. Start small with a customer, maybe a few critical connections, prove the value, and then grow from there.
And the numbers suggest it's working.
Seems like it. They reported 474 connected sites, $3.2 million revenue over a few years, impressive 80% gross margin.
And zero churn with 100% upsell requests. That's pretty telling.
It really is. Suggests customers are happy and seeing real value, wanting to connect more assets over time.
Their initial focus. Colombia, Brazil, Chile, and sectors like telecom, healthcare, manufacturing.
Yeah, seems like a solid beachhead strategy, focusing on those key use cases we discussed: CCTV, fuel levels, server power, energy water optimization.
And the pricing. Gateway-enabled SaaS core, Insight, autonomy tiers.
Right. It lowers the upfront cost less CapEx barrier and builds recurring revenue. Designed for high net dollar retention, meaning existing customers spend more over time.
Makes sense. And the focus on telecom, healthcare, and shopping malls as initial targets seems strategic.
Likely leveraging existing relationships or specific needs in those sectors. And that Phantom Shield gateway is positioned as a key differentiator.
Because it can handle those tricky legacy systems.
Exactly. That seems to be their edge. And landing that Intel contract, potentially 3,000 sites, is a huge validation.
It also helps understanding that Analytix is part of the larger GSS group, right? It gives them broader capabilities.
Yeah, GSS covers analytics, security, engineering, construction.
Yeah.
So Analytix can likely tap into that wider network and expertise, provide synergy.
Okay, wow. We've covered a ton of ground, from the core problem to the tech details to the business side. Let's try and wrap this up. Key takeaways.
Sure. I think the big one is just understanding that fundamental challenge. So much critical industrial infrastructure is effectively invisible from a data perspective. Old protocols, siloed systems.
Right. And that blindness, or the flip side, data overload, leads to real costs and risks from slow reactive responses.
Then there's the see, no, act framework. It's a really clear way to think about the solution.
First, see. Use something like the Phantom Shield Gateway to collect and normalize data from everything, making it visible and understandable.
Then, no. Apply intelligence anomaly detection, RCA prediction, using AI agents and federated learning to understand what's happening and why.
And finally, act. Close the loop through automation, orchestrating responses across systems without complex reprogramming.
And we saw tangible examples of this working in energy, fluids, CCTV, IT, delivering efficiency, savings, and better reliability. Plus, the market seems ready for it based on Analytix's traction.
Yeah, for me, the real kind of aha moment is just how powerful connecting these previously dumb, isolated assets can be when you add layers of AI. It's a shift from being reactive to proactive.
And maybe even eventually autonomous.
Exactly. And hopefully, for you listening, getting this overview gives you a real shortcut to understanding where things are heading with industrial operations, IoT, and AI. It's transforming these critical foundational sectors.
It really is.
So here's a final thought to chew on. As these AI agents get smarter and more interconnected, not just within one company, but potentially across industries, what kind of efficiency leaps are we going to see? What does true autonomy look like for the power grid or water systems or manufacturing?
And what does that mean for the people managing these systems? How do roles change? It's definitely something to think about.
Absolutely. Well, that's all the time we have for this deep dive. Thanks for joining us.